You know the feeling, right? You ask an AI what feels like a pretty simple question, and you get back, well, a novel, a wall of text. And it makes you wonder, is a longer answer really a smarter answer? Well, in this explainer, we're going to dig into some new research that cracks open why AIs get so chatty, and more importantly, we'll look at a simple trick that can teach them to be both brilliant and brief. You're about to see why thinking less might just be the secret to a much better AI.
Yeah, it's a super common frustration. You're just sitting there, watching the text scroll by, paragraph after paragraph, and you have to ask yourself, is this some kind of deep, complex thinking, or is it just digital rambling? We're going to figure out if all that extra length is a feature or if it's actually a bug.
So here's the key thing this research points out. A long answer is absolutely not the same thing as a correct one. A lot of the time, that extra length is just filler, verbose text that doesn't actually get you any closer to the real answer. The goal isn't just a long, meandering chain of thought, it's an effective one. And this isn't just, a weird little quirk that happens sometimes. It's a real recognized issue. Let's just call it what it is, the AI's verbosity problem.
And it actually has a name. They call it length inflation. See, what happens is that these really powerful AI models learn a kind of strange trade-off. They figure out that to get the highest score, to seem more accurate, generating a longer, more detailed-sounding answer is often the safer bet, even if a lot of that extra detail is just noise.
And trust me, this is not just some theoretical thing. Check this out. On a really tough math test, one model gave answers that were nearly 5 times longer than another model just to get the exact same score. That's not a small difference, right? That is a massive, massive gap in efficiency. In fact, sometimes that extra length can be a huge red flag. Get this. Researchers looked at times when a model came up with both a right answer and a wrong answer for the same problem. And when that happened, the longer answer was the wrong one a whopping 72% of the time. So that rambling, it's probably not a sign of deep thinking. It's a sign the model is just getting lost.
Okay, so that brings up the obvious question, right? If being super chatty doesn't always help and can even hurt, why do AIs learn to do it in the first place?
Well, the answer seems to lie in how these models are typically trained. There's a standard method called GRPO. And to put it simply, GRPO gives the AI a reward for getting the right answer at the end. But, and this is the really key part, it doesn't really penalize the model for how long or messy or roundabout its journey was to get there.
This analogy really hits the nail on the head. Imagine a teacher who only looks at the final answer on a math test and doesn't care about the work shown. The system accidentally teaches the model that showing more work, even if that work is super messy and repetitive, is a safe bet.
So what if there was a smarter way to teach them? This is where this new research gets really interesting because it proposes a really simple but incredibly powerful tweak to this whole process. Let me introduce you to GFPO, Group Filtered Policy Optimization. Now, it's not a complete overhaul, it's more of a clever twist on the old way. So, if the old method, GRPO, is the teacher who only cares about the final answer, GFPO is the teacher who says, okay, show me your 5 shortest, most elegant ways to solve this, and that's what we're going to learn from. And the process is actually super simple. It's just 3 steps. First, it samples. The AI generates a whole bunch of possible answers to a problem, way more than usual. Then, step 2 is filter. This is the secret sauce right here. The system automatically throws out everything except for the shortest, most efficient answers that are still correct. And finally, step 3, train. The AI then learns only from that small, elite group of concise, brilliant examples. It's basically being taught from the ground up to value elegance and brevity.
There's a quote from the paper that just perfectly sums up the whole idea. By sampling more at training time, we teach models to think less at inference time. Think about that. It's a brilliant trade-off. You invest a bit more computer power one time, upfront, during training, so you can get a model that's faster and more efficient for every single one of us forever.
All right, so the big question, does this simple little trick actually work in practice? Well, the data is pretty convincing. Let's take a look at the results.
Okay, so remember that math test we talked about? The results are crystal clear. The standard model,
The old way averaged almost 15,000 tokens for an answer. The new GFPO trained model, it slashed that down to 12,000. And here's the most important part. It did this without losing any accuracy. The model got a lot less chatty, but it stayed just as smart.
And it gets even better. When the researchers pushed this idea a little further, optimizing not just for the shortest answer, but for what they call token efficiency, which is basically the most bang for your buck in an answer, they managed to cut down that useless length inflation by up to 85%. That's a huge, huge improvement.
Okay, so we know the answers are getting shorter, but what is the AI actually cutting out? Like, where are these savings even coming from?
So before this new training method, the AI's reasoning is just full of this self-doubt and repetition. It's like you can almost see its inner monologue, right? Wait, let me double-check that. Let's recalculate. Is there a trick in the question? It's basically thinking out loud, and a lot of that thinking is just going in circles. But after being trained the new way, with GFPO, all that messy inner monologue just vanishes. The model learns to follow a much more confident, direct path to the solution. It trusts its own calculations and just gets straight to the point. The whole thought process is cleaner, leaner, and way more efficient.
So if you look at where all that extra text comes from, this chart tells the story. With the standard model, a huge chunk, a combined 80% of its whole output, is just spent on finding the solution and then verifying it. It's just a ton of digital trial and error and double-checking itself over and over.
Now look at the difference here. With the new GFPO method, those solution and verification parts shrink like crazy because the model has learned a much more direct, confident way to get to the answer. It spends way less time exploring dead ends and second-guessing itself. That's where the big efficiency gain comes from. It's like it trims all the fat right out of the core reasoning process.
So let's bring this all home. This is cool academic research, but why does it actually matter? For developers, and more importantly, for you.
Well, for developers, this is a pretty simple but super effective trick to build more efficient models. And for you, it means faster, clearer, and frankly, less frustrating AI assistance. It all boils down to this big idea. You make a one-time investment in smarter training, and that pays off forever, for everyone, in daily use. So what other AI bad habits do you think we should train away next? I mean, this research really shows that we can be a lot more intentional about how an AI thinks, teaching it good habits like being concise. It really makes you wonder, what other bad habits could we tackle next? Things like hedging or even hallucinating? It's a really cool path forward for making AI not just more powerful, but a whole lot more useful.